My name is Alice Agogino. I'm faculty of mechanical engineering. I also teach courses in other departments. I'm very multidisciplinary, and I teach courses in environmental engineering, education, the Haas School of Business, ethnic studies, and human studies. Well, I started out in anthropology, actually, as an undergraduate. I started anthropology because I really wanted to work with different cultures and with historical information, and just realized that in addition to just studying different cultures, I wanted to be involved and engaged, and I could see the potential of technology to alleviate poverty and make improvements. And so I actually changed majors to mechanical engineering. So when I was in anthropology, I really appreciate the skill set and the value of ethnography and anthropology. But it's an observational kind of science, and I really wanted to be proactive and work with communities to improve the design and improve the quality of their lives. So we've worked on any number of projects that might fit into the category of the question of combining the societal aspects of technology and application. So for instance, we work with Native American tribes on energy self-sufficient systems. We've worked with the Nation about 2 hours north of here to build culturally sensitive, sustainable buildings. But sustainable buildings that can be monitors, teach green building skills to the tribe members, increase employment, in addition to motivating the youth to go on to college and learn about engineering and energy. And right now we have near completing 2 of the demonstration homes, and families are about to move into the homes, and our next step is going to be to monitor the energy efficiency of the homes, but also to get the youth, the children in the homes, to do some of the energy sensing. So my lab, students in my lab work on a number of projects with civic engagement. In the past, we've also worked with migrant farm workers in Central Valley with pesticide protection for workers in the farm, but also looking more broadly at health issues for farm workers, both in the U.S. and in Mexico. And so we had a team work in Mexico and looked at the commonality between the problems in Central Valley and in Mexico. I have students that have gone all over the world. Right now I have a student who's on a Fulbright who had worked on the Darfur stove with Ashok Gadgil and is now measuring black carbon. He's developing an ethylometer to measure black carbon in the air. There are ethylometers that are in existence now, but they cost about $500. It's just too expensive in the poor regions of India that we're looking at, North India and the Tibetan Plateau. So they're trying to develop a low-cost ethylometer that they can attach to balloons, send it up the air, and find out what the black carbon is, particularly in regions where there's a multiplier effect with black carbon. I think engineers don't realize how important context is in almost any engineered projects, particularly those that have social implications. You need to understand the environment, the culture, the motivation of the people. I teach courses in what's called human-centered design, where you try to understand the needs of the people you're trying to serve. Maybe they don't even know those needs or know how to express those needs. So how to express the latent needs or look more broadly. For instance, when we went into the Pinoleville Pomo Nation project, they came to us asking to look only at energy efficiency. As soon as we did what I call an innovation workshop, we had the opportunity to work with the tribe to express their own opinion of the needs and also their own solutions. I'm a strong believer in co-design. And in the co-design process, you realize that what they really want is bigger than what they originally came in with. And so you have to reframe problems with this bigger context. So they wanted more efficient, energy-efficient homes. What they really wanted was tribal autonomy. They wanted to be independent, they wanted to have green jobs, and they wanted to educate their youth, in addition to the energy-efficient homes. So you have to step back and look at this broader context. In some areas, particularly low-income areas in the United States, or in the developing world, you also have to look at who are the strategic partners, what are the religious, political issues associated with what you're trying to do, what is the infrastructure like, both the technical infrastructure but also the social infrastructure. Where do people get health care? Where does the water come from? What are the interrelationships between governmental agencies and non-governmental agencies and so on? All of that really requires this combination of social attributes that you learn tied with your technical engineering skills. I'm really excited to be involved with a group of faculty in a graduate group called Development Engineering. Here's our brochure on this. But the idea is that it takes multiple disciplines to tackle some of the great societal and technical challenges on this planet. And in order to do that, students in engineering need to learn social science skills, social science students need to learn engineering skills, everyone needs to understand how to do an impact analysis, how to understand the economic impact in addition to the societal impact of social technical problems that we work on, and also come into a project with an understanding that you've got to look in the long run. How do you sustain it, both economically and technically over time? How do you sustain it in a way that you can scale up and really reach and have a larger impact? So on this program, we're starting out as a PhD minor, but we're offering courses, required courses and elective courses in this minor that any graduate student can take. The course that I'm teaching this semester is the core course, sort of the cornerstone course for the new development engineering program. It's called Design, Evaluate, and Scale Development Technologies. We cover human-centered design that I talked about earlier. We cover data mining technologies, how to use information and computing technologies, how to use sensing technologies. What are some of the developmental technologies that we can use in the developing world and for low-income areas in the United States? We are now thinking about, because public demand from the students, that we need to go beyond the PhD students. So a number of master students, both the MBA students in the Haas School of Business, Masters of Engineering students, and Masters of Science students, have asked us to consider looking at a certificate program in development engineering as well. There are many ways that students at UC Berkeley can engage in these socially engaged engineering projects. I understand that there's going to be a new website that is going to give you opportunities to be able to engage in these projects. Undergraduate research is a great way to be involved in these projects. The Development Impact Lab, funded by USAID, is providing a number of these projects. So there's the CellScope, there's the Darfur Stove project. There are a large number of projects in which they are funding graduate students who always mentor. You know, there are usually opportunities for undergraduates as well. There are a number of courses that students can take to learn more about social engagement. I'll make a plug for my course on Introduction to New Product Development, because I think it's really important that we start out the course with human-centered design. We start out the course with a recognition that design has an impact on everyone. And we really need to understand that impact and that context before we move forward with the technology. There's also the Global Poverty in Practice minor, and I highly recommend the minor, but if you don't have enough time in your curriculum to take all of the courses, you might look at some of the courses that are offered in the minor as well. So socially engaged engineering goes beyond the educational arena, even beyond nonprofits. Industry today wants students that come in with both soft skills and the engineering skills. So I was meeting earlier today with Bechtel, who really wants to have interns work with them in some of the developing worlds where they work in, because they specifically want students who can work in the context of the country that they're in and engage with the community as part of the design process. So you will learn skills that go beyond your technical skills and make you more valuable to just about any company that you might work for. I think it's critical. In fact, it would be my hope that all graduates from UC Berkeley are socially engaged engineers. It's critical for just every aspect of engineering. I'm in product design, and so what products we design for, who we design for, what are the implications of those design, both for the original customers and to the planet from an environmental standpoint, are just examples of how socially engaged design is critical to all of engineering.